birds.
Whoa.
Well, Sully is not the only one facing sleepless nights, fearing the consequences of bird strikes. The aviation bird strike hazard is a global and industry-wide issue affecting all aviation stakeholders, including airlines, air traffic controllers, wildlife personnel, aircraft manufacturers, and the traveling public. We Group 5 represent the safety analytical team at Boeing International, and today we will walk you through the statistics of bird strikes in the aviation industry and what do we at Boeing observe and recommend as a solution to avoid them. Now let us have a bird's eye view of the damages occurred due to bird strikes over the years 1990 to 2014 at various airports all over the US and the frequency of involvement of the airplanes of top aircraft manufacturers. The following visualization uses color as well as size to denote the data. The size defines what is the proportion of damages faced by the top manufacturers of aircrafts, and the color defines the different aircraft manufacturers. It is a surprising point to note that as opposed to the busiest airports in the US, such as New York, Chicago, etc., less crowded airports like Utah have the most recorded number of aircraft damages, and the reason for these statistics is that Utah is a hotspot for migratory birds and hence have a much large population of them flying in the skies. How do you think Boeing fares as compared to its nearest competitors? We at Boeing now want to go on a deeper level and understand how much damage have these top aircraft manufacturers faced over the years as compared to Boeing, and what are the competitive statistics as a percentage of flights. According to the data provided by Federal Aviation Agency, we can portray an area map which denotes comparison of the damages to aircrafts of various manufacturers due to bird strikes over the time period 1990 to 2014. We observe that Boeing is amongst the most impacted manufacturers along with Airbus. To talk in terms of the percentage effect of airstrikes on various manufacturers, we can observe this particular pie chart where we see Boeing dominating the statistics, followed by Cessna. And when it comes to comparing percentage of aircrafts responsible for fatalities, Boeing again dominates, but this time it is followed by Airbus. So far, Boeing dominates all the statistics, but unfortunately, these are not the statistics we would like to top. So now let us try to go to the root cause of these massive damages in order to get a deeper understanding of our problems. Do you think a bird's size is more dangerous than its speed? A very obvious and important factor involved in bird strikes is the relative speed of the birds. Let us have a closer look at this visualization. It was formed to depict the impact of various bird species on the aircraft damages. It includes characteristics of these birds such as their speed, name, and the number of aircraft damages that they have caused over the years. From the graph, we can observe that the top bird species responsible for maximum airstrikes are gull and hawk. One peculiar observation, although, here is that even if anatomically the gulls are smaller as compared to geese, they are responsible for more airstrike incidents. Thus, as a conclusion, we figure that the size of the bird, contrary to the general perception, does not play a major role in bird strikes. Can visibility be an important factor responsible for such strikes? There are some very common misconceptions. For example, birds don't fly at night. Birds can detect and avoid airplanes. Birds dive to avoid an approaching airplane. Well, we have come across such data which defies these myths. To understand what we observe, let us have a closer look at the following visualization. We observe that clear skies have experienced maximum bird strikes and consequent aircraft damages as compared to cloudy skies. For instance, in clear skies, maximum damage occurs between the time 10:30 am to 4:30 pm. It is important to note that these high statistics, incidentally, are in sync with the spring session, which is from March to May of the year, as well as with the fall season, which is from September to November. This should not be a surprise to those of us who are aware that this is the time when most migratory birds take flight. Also, we recorded lesser airstrikes during cloudy weather, which clearly proves that visibility is definitely a factor responsible for bird strikes. The next step in our analysis is to figure which parts of our aircraft are the most impacted by bird strikes, and it also is in our interest to know during which phase of the flight do we face the maximum chance of hitting a bird. Let us now have a closer look at the following visualization. This particular dashboard is a collection of various observations in analyzing Boeing's most damaged commercial planes. It represents a total of 3 factors. The heat map here represents which model faced maximum damage over the years. The bar chart represents which part of the aircraft is impacted the most, and the pie chart represents in which phase of flight do maximum airstrikes occur. From the various parts in the dashboard, we conclude that model B737 has reported maximum aircraft damages with a total of 67,414 number of bird strikes. It is interesting to note that the nose of the aircraft, despite of being the first point of contact, records the least damage, whereas the tail follows the engine by recording the second highest number of damages, which accounts to 27.64% of the total aircraft damage. Finally, we see that the maximum airstrikes occur during the ascent and the descent phases of the flight. Up until now, we have noted the major factors responsible for aircraft damage due to bird strikes. What could be done as a solution to reduce financial losses that Boeing faces as a consequence? All airports in the world follow the protocol of issuing warnings in case of natural disasters, air traffic, bird traffic, fire, and so on. Interestingly, we noted that we recorded lesser aircraft damage incidents when we were warned of a possible flock of bird in our flight route as opposed to when we were unaware of such traffics. To prove our point, let us have a look at the following visualization. Let us compare the statistics of maximum and minimum number of aircraft damage incidents reported. The data shows that the year 1992 observed least number of damage when no warning was issued for unattended bird strikes. As the year progressed, the number of strikes increased from 923 to 1456, as can be seen in the year 2000. Now let's compare it with the damages for air traffic control who took this issue seriously. As you can see that the same year 2000 observed only 210 damages, which is almost a 85.5% reduction. These statistics securely help us deduce that with an efficient warning system, we can help reduce the number of aircraft damages and consequently make air travel more safe. To summarize, despite being one of the top aircraft manufacturers, Boeing has suffered maximum damages to its aircrafts when it comes to bird strike. The speed of the bird has more impact on bird strikes as compared to its size. With the aid of warning systems, Boeing can reduce the number of aircraft damages due to bird strikes. Finally, these are our source credits. The aviation data comes from Kaggle.com and the aircraft bird strike also come from Kaggle.com. Thank you so much for your attention. Have a good day.